Welcome back. Today we're going to talk about a very familiar formula, the distance formula. The distance formula is based on the Pythagorean theorem. Now, we're going to go through Pythagorean theorem here in a few minutes, but generally the distance formula looks like this. D equals, and then we've got a big square root, x2 minus x1 squared plus y2 minus y1 squared. If you know anything about the Pythagorean theorem, it involves a couple of squares. This here is really a length. And this is a length. Remember when we talked about using a ruler and subtracting the coordinates? Well, really, that's what this is talking about. It's the distance between the x coordinates and the distance between the y coordinates. So let's use the formula to calculate a length. We're going to find AB and CD, and we're going to determine if AB is equal to CD. Remember, of course, this means the length of AB. So let's find AB. The distance equals, and I'm going to use this formula up here. I like to label the points so that I know what is what. So since I'm finding AB, I'm going to do x1, y1, x2, y2. Let's look at this distance a little bit more closely. x2 minus x1 would be 5 minus 0 squared plus y2, which is 1 minus y1, which is 3 squared. And I'm going to drop down here to the next line. And so this is 5 squared plus negative 2 squared. Well, if I do a little bit of reduction here, 5 squared is 25. And negative 2 squared would be negative 2 times negative 2, which would be 4. And so this is square root of 25 plus 4 equals square root 29. We can leave that as the length of AB for right now. Let's find this other distance. I'll do this one in blue. The distance equals, once again, I'm going to go ahead and label here x1, y1, x2, y2. Let's plug and chug. This is going to be x2 minus x1, a little bit more intricate here with the negatives, but that's okay, we're not afraid. Negative 4 is going to be y2 minus 1. And of course we're going to square both of those values. Let's reduce this. Negative 3 minus a negative 1. So anytime I subtract a negative, it's the same as adding. So this is going to be negative 3 plus 1, which would be negative 2 squared. Plus, and then over here I have negative 4 minus 1, which would be negative 5. And we're going to square that. Quickly, you should realize what's going on here. Negative 2 squared would be negative 2 times negative 2, which would be 4. And negative 5 times negative 5 would be 25. So we end up with the square root of 29. Now notice, I didn't have to actually find the square root of 29. And I can see that even though I didn't find the square root of 29, I know that these two are the same length. So AB equals CD, or AB, the segment, is congruent to CD, the segment. See if you can do the next one. If you'll notice over here, we have a diagram, and you can find EF and GH here and here. Hint, use the coordinates that are given on the coordinate plane. Find the distance and see if they are congruent. Let's talk Pythagorean theorem real quick. Pythagorean theorem. You have to have a right triangle Notice I have a right triangle here. And the Pythagorean theorem is a squared plus b squared equals c squared. A and b are legs. C is the hypotenuse. And I'm going to put a note on that: opposite of the right angle. Okay? So that's all there is to it. It's a plug and chug kind of a thing. Square A, square B, set it equal to c squared. Let's see if we can do such a thing as this. The problem is this. Use the distance formula and the Pythagorean theorem to find the distance to the nearest tenth from A to B. Well, if I use Pythagorean theorem, that's a squared plus b squared equals c squared. Well, I don't have A and I don't have B, but I could find that length, right? And if I find either A and B or the distance from A to B, I could check myself. So let's see here a second. B equals what? Well, what I'm going to do first is I'm going to count. 1. You can't really see that, can you? 1, 2, 3, 4, 5. So the length of B is 5. And I'm going to put count boxes. And the length of A, I'll count boxes again, labeling again in a yellowish color. 1, 2, 3, 4. The length of A is 4. So I'll count boxes. And if I say A squared plus B squared is equal to C squared, I would have 4 squared plus 5 squared is equal to C squared. Well, this is 16 plus 25 equals C squared. So 41 equals C squared. I'll take the square root of both sides. Square root of 41 is equal to C squared. Well, that's approximately 6.4. That's a pretty good estimate. Let's see what we get when we do the distance formula. The distance formula equals, remember, square root x2 minus x1 squared plus y2 minus y1 squared. I'll label, and this is going to be x1, y1, and this will be x2, y2. Let's do a little bit of subtraction. x2 is 2 minus a negative 2. I'll square that and add it to y2 minus y1. Let's reduce. Negative 2 minus a negative 2 would be 4. So that'll be 4 squared plus negative 2 minus 3 would be negative 5 squared. Hopefully you see where this is going. Square root of 16 plus 25, square root of 41, which is approximately equal to 6.4. Notice, I get the same answer in both cases. This is good. That means that the Pythagorean theorem works, but also the distance formula works. I would like for you to try this next one on your own, see what you come up with. Alright guys, thanks for watching. We'll see you next time.